Hello, my name is Vitaly Rudnitsky. I am one of SAP Developer Advocates, and I am the host of the Oktoberfest Data and Analytics Week. We started this week with presentations actually today. We had a session on demystifying data science in enterprise in the morning, my time. That session is recorded, so you can watch it at your convenience as well. And now we are continuing with Alan Simon, who is going to present the modern enterprise data landscape. Later this week, we will have as well one more presentation presented by myself, actually, on the topic of data visualization, plus a series of panels with data science experts and book authors. Closing this week will be Let's Talk Coding for Kids, with two of our colleagues developing Snap programming environment. So the program is quite full for this week. I'm going to share the link to the complete agenda in the chat. We encourage those of you watching us live to ask your questions, and I will read these questions to our presenter at the end of the session. And with that, I would like to pass the microphone, if we can say so, to Alan.
Thank you. Hello, everybody. I'm very glad to be here. So what we're going to talk about for the next hour or so is the modern enterprise data landscape. And let me just give you a brief introduction about myself. I've actually been doing enterprise data for many years. Going back to the mainframe days. I've been a consultant, hands-on field consultant. I've run global and national practices. I've written books about various topics, including enterprise data management and various flavors of that. And I've also been a university instructor. So I come at the whole discipline of enterprise data management from a number of different angles, both old and new, as well as think of it as hands-on, big picture, and also from an academic perspective. Now, the best way to get your arms around this whole discipline of enterprise data management is to actually take a real brief time machine trip back to right around the 1960s, 1970s. And if you were to pick up a data processing textbook back in those days, you would see a diagram that looks something like this, where you'd have a number of different business applications. And in the middle of those applications, you would find what they would call a common database. And funny, back in those days, database was usually 2 words. And the whole basic idea is that you would have sets of applications. They would each do their respective functionality, but they would share data. And, you know, everybody can pretty much get around that premise. And here's a little fun fact. If you go back 60 years to one of the earliest high-order programming languages, a language called Jovial, they actually used to have a construct in there called a COM pool, which stood for communication pool, but also referred to a common pool of data that different Jovial programs would share. So this idea of shared enterprise data, sort of this single copy of data, is one that actually goes back to some of the earliest days of computing. Well, what we know is that that vision never really happened. And even on a mainframe system, you would have heavy-duty data fragmentation. You'd have a mix of disk systems and drums and cards and tape systems, and different applications would have their own data sets, which led to a high degree of data fragmentation rather than a common pool of data. And of course, that becomes a problem because these applications typically need data that originates elsewhere. And what you would have to do is create a number of these different one-off data feeds among the different stores of data. And that problem actually became worse in the 1970s and 1980s when we had mini computers introduced and eventually personal computers and local area networks, because we still had that same fragmentation problem, but it was now distributed across different platforms. So you had things like character set conversions and all the other things we needed to do in that day. So basically, we had a very severe data fragmentation problem when we dealt with our enterprise data. And that was just for the operational and transactional side. Don't forget about cross-application reporting. Typically, what we needed to do was pull out data from these various different stores of information and pull them into a set of extract files, typically that were tied to certain reports or certain business functions. So now we had a fragmentation problem on both the transactional side and the enterprise side. Now, the good news is we hit the 1990s, especially the middle part of the 1990s, and it looks like we finally have a solution to this problem. And the solution actually had two different facets to it. One would be the ERP space, where instead of a set of different applications, each with their own store of data, you would have one overarching software package that would do accounting and finance and HR and planning and manufacturing and all the other different functions. And within that ERP package, you would have that common store of data. And then the 1990s was also when data warehousing came onto the scene, and it became at least conceptually, an idea for one-stop shopping where we would pool our data, organize it, reorganize it, structure it to support reporting and analytics and the overall business intelligence world. So now we've seen a consolidation of both our transactional data and our analytical data. And both of these were driven largely by the whole Y2K resolution that we needed to go through at the time. Companies that decided not to fix their old COBOL and Fortran programs and decided to take the plunge into what was then modern technology would then implement ERP. Well, that seemed at least like it might be the resolution to our enterprise data problems. But the reality is, if you look at many organizations, and your enterprise might be like this, you might find not one, not two, but maybe 3 ERP systems, maybe 5 or 6 ERP systems. If you work for a global multinational, you'll find numerous data warehouses and data marts. So essentially, we see a consolidation of our data, but then we see a refragmentation of our enterprise data as well. We still have a hard demarcation between our transactional and our analytical sides, and we see just multiple instances, either across brands, perhaps across geographies, whatever the situation is. We really are still outside the solution space for true enterprise data management. So we need some help with the problem. Now, the best way to address this problem, and some organizations have been doing this for a while, some organizations are still living with this fragmentation problem and need to figure out once and for all, how do they get past that, to not only for technology reasons, but to compete in business. And you can decompose the problem space into two companion solutions. One has to do with enterprise scale data architecture, and the other has to do with enterprise scale data platforming. So let's talk about the enterprise scale data architecture first. In a perfect world, you would have what we saw before, a single enterprise system, but not just for ERP. You would have an integrated package that does ERP and customer relationship management, CRM, supply chain management, product lifecycle management, supplier relationship management. All of those functions would either be part of the same package, or they would be so closely and tightly integrated as provided by a single vendor that there'd be, for example, a backbone in there. And for all intents and purposes, it could be thought of as a single store of data that all of your key enterprise applications tap into. And likewise, you would have a single enterprise data warehouse, not a set of independent data marts or other fragmented stores of analytical data. And from that EDW, that's where you would get the bulk of your enterprise business intelligence and analytics and your reporting, your data visualization, and everything else. And in fact, in an even more perfect world, you wouldn't even have that demarcation between your transactional data and your analytical data. A long time ago, I used to be a product manager for distributed database management systems. And one of the things we were trying to achieve was a unified set of data for both analytical and transactional purposes that would have some level of distribution and decentralization underneath, but you would have some abstraction and a semantic layer on top of it. Well, if you think about the 1980s and the early 1990s, the technology we had to work with just wasn't nearly as mature enough to do that. So this is certainly something you can keep an eye towards, and we'll talk later about modern enterprise data platforming and how we're actually heading back in this direction or towards this direction. But in the meantime, we do have to live with grounded in reality solutions. You do have to try to address the challenges you have today. And this is where what your overarching objective should be is to balance both vision and pragmatism. Have an eye towards the future, have an eye towards almost a utopian approach to your enterprise data, but at the same time, you still need to be pragmatic. So there's a set of techniques you can use. One of the most prevalent techniques is to build very carefully architected data pipelines throughout your enterprise. So beginning at the sources of your data, whether it's traditional applications, whether it's IoT devices, whatever it happens to be, you're going to be generating, as we all know, large volumes of data over and over and over. Some enterprises generate far more data than others, but the reality is even a moderate-sized enterprise and even in maybe an industry that traditionally is not known as a data-intensive one, just the way we do business today, you will be generating a lot of data. And what you need to do is carefully architect pipelines to sort of shepherd that data along the pipeline into places where it can be organized and stored and consumed as efficiently and effectively as possible. Now, some people, maybe you've read about data pipelines and you've seen some of sort of the backlash to data pipelines, because essentially what we're doing is copying and duplicating data as opposed to a physical good. And one of the instinctive reactions is, well, why am I copying data? It's just a bunch of electronic bits. Why am I not going back to its original source? And if you do take a step back, data pipelines do have, think of them as challenges. You are proliferating data. You are requiring more storage. Every time you copy or propagate data along that pipeline, you run the risk of, think of it as quality leakage. There's always the chance of introducing either an outright error, a timing problem, a referential integrity issue, whatever it happens to be. Think of it as governance leakage. You might have a very robust master data management program, yet as you propagate your data along your pipelines, you potentially are introducing MDM issues. You're leading possibly to analytical fragmentation. And certainly, as you're going to see with one or two of the pictures coming up, pipelines introduce architectural complexity. They are a reality, and complexity is inherent in the way we build modern systems. But the broader our pipelines are, we do run the risk of and need to deal with that architectural complexity. It's not necessarily a bad thing, but it is a reality. And to those points, never fear. Those are true about data pipelines, but again, they are a reality in our environments. So there's a couple things you can do, and I'll go through sort of some of the tricks of the trade when it comes to data pipelines. The first thing to do, and this is true, this transcends data warehousing and data lakes, data mesh, all the other newer approaches or offshoot approaches, older ones like data vaults. No matter what you're doing, you need to zone your enterprise data, particularly in the analytical side of bringing data in for consumption. And by zoning it, I mean If you think about what ETL, extraction, transformation, and loading does, or ELT paradigms, extraction, then load, and then you do your transformations, one of the first things you need to do is move raw data along those pipelines. So what you need is, whether you call it a bronze zone, and then you refine the data into maybe a silver zone, and then curate the data into a gold zone. Those are common terminologies you will see in the data lake world. Or maybe you just use the terminology of raw zone, refined zone, or curated zone. Or maybe you actually adopt data warehousing terminology, staging layer, the transformation layer, and then the performance layer, where you would have your star schemas or your snowflake schemas or some other types of optimized storages. The point is that as we build our data pipelines, don't think of those pipelines as monolithic entities in and of themselves. They need to be built in a way to, number one, ingest raw data, and number two, transform that raw data or refine that raw data, and eventually curate that raw data. And you're going to see coming up, you actually can do some mixing and matching, and there are some clever little tricks you can apply to your enterprise data as you're doing this. But the whole point is, as you're building data pipelines and as you're addressing your enterprise data challenges, one of the first things you need to do is at least logically think in terms of different layers or different zones. The other thing with your pipelines is that they need to be smart and they need to be flexible. Now, this picture, as you look at it, it's one of those ones that overwhelms you when you see it. And I'm not going to go through every piece of this, but the whole idea is, as you build your pipelines, you have a number of mix and match paradigms that you can use as applicable for different pieces of those overall data pipelines. So, for example, let's say you're a hospital setting and you have an enterprise health records or enterprise medical record system that handles everything going on in that hospital, all the way from patient admissions to labs and pharmacy and surgery and patient bedside care and just basic facilities management, then discharge and billing, the whole thing that you would find in an enterprise system for a medical setting. Well, what you see here is, think of it as kind of the ultimate in mix and match here. So you have a mix of batch data feeds as well as streaming data feeds going into, and we'll just call it a data lake, but you could use any terminology you want. The batch data feeds are denoted by those little boxes flowing along some of those lines, and the streaming data has a little water symbol and then an arrow with data flowing along there. Now notice, part of this overall data pipeline, and essentially you can think of this as multiple, kind of parallel pipelines. Some of them fit the classic data warehousing ETL paradigm that we've been doing for 30 plus years. So we see patient administration data and lab data and pharmacy data and our facilities and inventory data coming in via batch transfer, landing in raw form in a bronze zone. The whole purpose of that bronze zone or raw zone or staging layer is to ingest data as quickly as possible and as non-intrusively as possible with our operational systems, the sources of that data. So we land the data in there. We don't patch it up. We don't fix it. We keep it in raw form, possibly even erroneous form. And then along the pipeline, we'll do the transformation side of ETL or whatever refinement and enrichment we're going to do to move it along into a refined zone or a silver zone or a transformation layer. And then over on the right side, some of that data is further repackaged into maybe dimensional models for classic data warehousing or curated data packages that we'll use for machine learning models or whatever it happens to be. So basically, along this overarching enterprise data set of feeds, you have certain feeds that could well be part of classic data warehousing. Yet at the same time, we're intermingling that with other pipelines which use streaming technology as the batch technology. And notice something interesting about that. We see radiology data streaming its way right past the bronze zone. It doesn't even land in the bronze zone. It lands right in the silver zone. We see surgery data that comes into the bronze zone, so our raw data, and it gets then refined and packaged into the silver zone and then further sent downstream into the curated data packages or the dimensional model. So essentially we have two parallel streams of data, but each land in different parts of, in this case, our data lake. And then you have, notice the patient bedside care data. So in a hospital, you might have these patient bedside monitors. In this case, we're not landing that data or persisting it anywhere in what you would think of as a classic data lake. We're actually feeding that right into streaming analytics. So you look at this picture, and at first glance, it seems messy. It seems you don't have neatly lined up, arrows and lines and different artifacts on that diagram, but it's meant to be reflective of what a real world enterprise data environment would be, kind of this mix and match of different techniques and sort of different zoning across your respective data pipelines, all coexisting as part of your big overall enterprise data picture. Now, here's a couple other additional tricks of the trade as you work with your data pipelines. So one thing, let's say your organization, you're an energy exploration company, and you have remote drilling wells up in the American Rockies or somewhere else around the world that's relatively hard to reach. And what you've done inside those wells, you have sensors that read temperatures and pressures and everything else. Well, what you want to do is do some analysis of the data. And in this particular case, we're going to feed the data into our bronze zone in raw form. Now, temperature readings and pressure readings are pretty much discrete pieces of data. There's not a lot of refinement or anything else that we really want to do with that. We essentially want to move that data along our pipeline. So you might, if you go back to one of the challenges of data pipelines, is this kind of proliferation and duplication of data, potentially causing excess storage. And you might resist that idea of, why am I just going to copy data once again when I'm not really doing anything to it? Well, the reality is certain types of data, if you don't need to do any refinement or enrichment, and all you want to do is move it along the pipeline, you could do exactly that. So think of it as kind of a conveyor belt. So you can copy it if you want. You can sort of move or reposition it from the bronze zone into the silver zone. And as you see these rapidly ingested streams of data, you're not persisting data in your first layer, your bronze zone, your raw zone, your staging layer, that you don't need to. So because it really has no value like that. So essentially, as you're looking at any given data pipeline, what you could do is make these intelligent sort of data-driven decisions or usage-driven decisions about the value of the data at different stages of its life cycle and whether or not it needs to be persisted and then managed. Here's a similar example, but one we want to handle a little differently. Let's say you're ingesting tweets, and what you want to do is do some sentiment analysis and text mining and other aspects for those tweets. So you have some sort of a scraping engine which will go out to Twitter and pull in the tweets about your particular company using hashtags or just basic text mining. So you bring in that tweet in total raw form, you land it in your bronze zone, and you don't do anything to it. Now what you want to do is, number one, try to match that up to see if it might be an existing customer who actually tweeted that. So you'll look at the ID, maybe match it up with some structured data that you have, and you realize that, yes, it is one of your customers. So you augment that raw semi-structured data with a customer ID and a customer name. You then do a little bit of text mining on that tweet to do some sentiment analysis, and you decide that it's a very positive tweet about your company. So essentially, you have now taken raw data, you've refined and enriched it. So the question then becomes, do you need to persist that raw tweet just by itself, as well as a copy of that raw tweet now augmented by the refined data, the ID, the name, and the customer name, and the sentiment? And the answer in this case is no. What you could do is think of it as repositioning this package of data, this refined and enriched data. So it's no longer wherever it's sat, wherever it landed after it's augmented, it now is considered to be part of the silver zone, your refined data zone, as opposed to your bronze zone. So it's another little trick rather than just dumping raw data that you no longer need. Even if you change data, you may look at the original form of that data, in this case, a raw tweet, and say, you know what, we don't really need this because that raw tweet is still there as part of that enriched package. And essentially you reposition it into the silver zone. Here's a similar example, but one that's a little bit different. Let's say you're bringing in images, and what you want to do are two things. Number one, enhance that image using refinement techniques. So you want to sharpen the features and reduce noise, all the video editing kind of image editing kind of techniques you do. And then the other thing is, once you now have a refined and enhanced image, what you want to do is a little bit of facial recognition and match that image up with a specific customer, if indeed it's a specific customer of yours. So we take this raw kind of fuzzy image in, we sharpen it, we enhance it, we do the facial recognition, and we realize that it's our customer named Jane Williams. And Jane Williams, with this sharpened image, augmented by this enriched data, the customer ID and the name, is going to be part of our refined data sitting in our silver zone. So now the question needs to be asked, what about that original raw data we brought in, that sort of fuzzy image, possibly with some noise and background stuff that we filtered out? Should we keep it? Should we get rid of it? And there is no one right answer, but one option to sort of retain your raw data, even if you don't think you're going to need it, or even if you're only going to be using it to test out new facial recognition algorithms down the road, you don't necessarily need to keep that raw image in your active storage or your normal storage within your bronze zone. You could put it into some sort of deep archive or cold storage, where you're paying a lot less for the storage, no matter whether it's your data center, whether it's a cloud service. You have some sort of an archiving facility where you pay less. Should you need it, though, it will cost you a little bit more to retrieve that data. But the reality is, it's not going to be frequently retrieved data. It's something that will either be sparsely or infrequently retrieved, or maybe never retrieved at all. So again, what you want to do is take a step back, look at the types of data you're bringing in, look at the usages of the data, both now and in the future, and then look at what your options are. And there is no one size fits all solution for different types of data and different feeds. Another thing, if your organization or enterprise has any sort of edge analytics that are part of your architecture, so you're doing the analytics at the edge of the enterprise as opposed to from a data lake or some sort of centralized store. Go back to that remote drilling well scenario. Let's say those temperature and pressure readings, along with video that are buried inside the well, let's say they're all being used to try to preemptively figure out if you might have a problem, let's say an impending failure of equipment. And then if so, shut down the equipment before it winds up breaking on you. And that's the point at which you send out a remote crew to fix something. So the idea is try to catch a problem either early or before it happens. And that's part of your overall preventive maintenance model. And you're using analytics at the edge. So those data are being consumed and analyzed at the edge of the enterprise, but the enterprise also has your data lake and or data warehouse or combination thereof for your other data. Well, the two not only could coexist, you don't have an either or situation. So let's say you have 4 different wells, each of which are doing their respective edge analytics. You can also have that data as well as being used for the shutdown or keep running decisions actually at the wells themselves. You can also feed the data via batch or streaming or whatever is appropriate into your data lake, data warehouse, data mesh environment, whatever it is that you happen to have at the enterprise level. So essentially what you're doing, you're linking up your enterprise data at the edge, as well as the core, the centralized enterprise data. Now, there's all kinds of other tricks you can do with your data pipelines, but let's switch the discussion for a moment over to enterprise scale data platform, because this is the other key part of your solution as you try to get your arms around your enterprise data. So let's take another little look back, because this is relevant for this discussion. So if you go back to that time frame when we thought we would have enterprise, centralized enterprise data, we also actually had a couple different, and this is the pre-relational era, a couple different primary go-to solutions. We had, think of them as prehistoric databases, the codicil network databases, IMS hierarchical databases, other non-relational database solutions. You had ISAM and VSAM files, flat files on IBM mainframes and equivalents and other mainframes. Then we get into the early 1980s as relational databases start to come on the market. And for about 15 years until the mid 1990s, you see this progressive growth of the usage in relational databases. But at the same time, you still have those same legacy platforms that I mentioned a moment ago still in existence. You have relatively new object-oriented database management systems. You had knowledge-based management systems. You had fourth-generation languages or 4GLs that had these, think of them as quasi-relational databases underneath. You had first-generation multi-dimensional databases. All of those were coexisting at the same time. And essentially, you had a lot of choices for your data platforms. And maybe, in fact, you had too many choices. What happened then was you got to the mid 1990s, and the relational database engines, now being about 15 years into their lifespan, really picked up steam. And you saw, think of it as the great convergence in the world of data management. So relational databases were enhanced with even more OLTP, online transaction processing capable facilities. So they could be used for mission critical, high volume OLTP applications. We introduced things such as star schemas and bit-mapped indices to help relational OLAP or ROLAP for the data warehousing world. Some vendors introduced object-oriented extensions. We had multidimensional extensions. In some cases, you had massively parallel processing extensions for very large database capabilities. So for a long time, essentially, in this world of enterprise data management, your go-to solution was a relational database management system. You still maybe looked across different vendors, but really, for the most part, your go-to solution was an RDBMS. Now, though, we get to the early 2010s, so a little more than 10 years ago, you have the whole Hadoop world with the HDFS, the Hadoop Distributed File System, and other first-generation big data platforms. You have columnar databases, NoSQL databases, graph databases, next-generation data virtualization, which is incredibly important. And really, we're back to the future database edition. We have a multitude of platforms to choose from, which is always good to have choices, but what you saw in a lot of enterprises was we were back to platform proliferation. So think about the two sides of this enterprise data picture, the data picture as well as the platform picture. When you have proliferation on both pieces of those, it gives you complications and most likely trouble. So once again, we need some help. The good news is, and there's always good news in this enterprise data picture, think of it as the great convergence 2.0. multimodel databases where you have these next generation data management engines that support OLTP and support analytical processing. They support different approaches and different views of their data. They make extensive usage of memory to help improve overall performance. Essentially, we're now at the point where no matter what your legacy data management footprint happens to be, it's definitely worth taking a fresh look, just like we did, way back in the mid 90s. And we tried to address our proliferation of data platforms then. It's worth taking a look now and saying, what can I do as far as rationalization to reduce the number of footprints I have out there and bring some order to my enterprise data platforms? Now, both of those are, the data platform side and the data architecture side. They're certainly valuable. There's a mix of big picture and down in the weeds, hands-on type of solutions. You still need to turn vision into reality. So in the Data Lakes for Dummies Data Lakes for Dummies book that just came out, I took this longstanding methodology that not only I have used, but probably most of you have at least seen it in some form, where you begin with an assessment, you do architecture work, and then build a roadmap with some strategy baked in. Dummies books, if you're familiar with them, they like little catchy phrases and catchy content. So I turned that methodology about data lakes into a methodology called a lake. It starts with assessment, moves into a lofty vision, then moves into architecture, then moves into the kickoff activities to get you going, and then finally the expansion and enhancement. And if you look at the first letter of each of those, it spells out a lake. Now, the fundamental premise of most methodologies is that it's really difficult to define a destination and reach a destination if you don't know what your starting point is. Unless you're starting with a total clean slate in a greenfield situation, you have some sort of a starting point, so you do need to understand and assess. Now, when it comes to your enterprise data, my advice is don't just look at the data. Look at the analytics side, how that data is being used, and then the data management side itself. And you see here a little organization chart, if you will, that has both enterprise analytics and enterprise data as part of the assessment. And even then, you see a little bit more of a breakdown. The overall continuum of enterprise analytics. So most of us are familiar with descriptive, predictive, prescriptive. You can also add in diagnostic and exploratory. But basically, no matter which taxonomy you use, there is a continuum of analytics. You want to see how well are you using your data for that. Are you then driving it towards true prescriptive analytics? Actually making decisions and actually taking actions from the data. So there are so many different techniques you can use. Many organizations have internal standards, so you pretty much can adapt this overall architectural framework to anything that you're doing internally. And as far as your representation, maybe you use Harvey balls where you rank something from the worst to best. So for example, you take your enterprise analytics, you have your continuum, you break that down, let's say even descriptive analytics. How well are you doing in terms of that rear view mirror look, the tell me what happened types of questions versus tell me what's happening right now? Your diagnostic, how well are you making use of data that's factual versus actually building models, and you're dealing with hypotheses to do diagnoses. And you see, no matter how you build your taxonomy, and this is just a representative example, what you would do then after you do your assessment work, you would then graphically on one slide throw the Harvey balls in this case on there, so someone could see what's working and what isn't working very well. You do the same thing on your data side, so you can look at how well you're doing to minimize fragmentation of platforms, how well your stage data is in terms of adherence to certain standards and models. Are you controlling redundancy across your data pipelines, or is it out of control? Is your storage optimized? And then the whole governance picture. And again, just a representative example. You could, if you want, go with some sort of a numeric score. You could also look at your current state in different ways. You could look at your incoming raw data, your data overall data quality and governance, your velocity and latency of the data, so your mix of batch and streaming data, your component architecture, and you see underneath there's think of them as subgrades. How complex is each of these? Or how compliant are you with industry best practices or internal standards? How easy or difficult are any of these to support? And I always like, when I do this model, to have something I call the tension index. Are any of these essentially causing a lot of grief around your enterprise because of things not being so great? And let's just say what you'll do is you'll do surveys or other techniques. You get aggregate scores, you weight them, you average them, however you want to do your model. And let's just say you set 2.5 as the cut line between things being in good shape versus below, in this case, 2.5. Think of it as a hotspot, something that is causing problems that you need to address. There's no one methodology for assessments. There are lots of them out there, and you can adapt any of this. You can use whatever you have. But the point is, you do want to do an assessment of what your current state is. You also want to paint a picture for what tomorrow is going to look like, because it's more about building data pipelines and migrating to a new modern enterprise data platform. You want to show what is going to happen when this actually occurs. So, for example, one of the things I like to do is have that day in the life. So whether it's 15 or 20 or 40 different now versus the future kind of pictures. So let's say someone works in an insurance company, and the way things work today, if someone's processing a claim, that insurance claim adjuster needs to go out to 6 different data sources for a mix of structured, semi-structured, and unstructured data, mix of audio, video, pictures, and then think of it as a human-based synthesis of that information to then do his or her job. Whereas tomorrow, maybe the picture is that data is fed into, again, data lake, data warehouse, data mesh. That's not important. Some sort of a modern enterprise data environment where that data all is fed via various mechanisms into a broad layer. It's transformed, and refined, and enriched. It's cleaned up, and then winds up in a nice little neat curated package that someone, an insurance adjuster, can tap into for one-stop shopping. Now, we've been after one-stop shopping for analytical data for a long time. This is just the latest incarnation. You just want to paint a nice, compelling picture to help drive the overall work down there. And the other thing, as you look at your architecture, one of the things I really would strongly recommend is consider multiple options. Don't necessarily jump on the first solution that jumps out at you. So let's look at a real simple example where you're going to have a classic enterprise data warehouse, and you're also going to have a data lake. One way to have these guys coexist with one another is to have some sort of a split feed architecture. So batch data from a variety of different applications is fed via ETL in your EDW. Some of that same data is also fed via batch into your data lake. And then you also have some data that streams its way into the data lake. So if you're familiar with both the Kappa and the Lambda data feed architectures, this would be more of a Lambda architecture for the data lake. But the point is, we have multiple feeds coming out of our source systems in this particular scenario. Another option is your EDW could be, think of it as a front-end supersized staging area only for the batch data for the data lake. So you see now there are no batch feeds into your data lake at all. You only have streaming feeds. So this would be what would classify as a Kappa architecture. All the batch feeds go into the EDW, and then some of that data is further fed downstream into the data lake. So that's another option. Here's a third option. All the data, both batch and streaming, makes its way into the data lake. So we're back to a Lambda architecture. There are no direct feeds at all into the EDW, and the EDW essentially functions almost like a dependent downstream data mart after the data lake, doing double duty as a supersized staging area for the EDW. And it's not a matter of which of those 3 architectures is the right one. any of them could work, but what I strongly recommend you do as you're looking at your data pipelines, as you're looking at your platforms, as you're looking at building your next generation enterprise data architecture, don't necessarily jump on the first solution the first architectural solution that happens to surface. At least consider a couple other could be's until you decide on your should be. And then once you have all that done, your last phase, I mean, it's really your roadmap, but if you go back to that A-Lake methodology, the E would be for expansion and enhancement. Whatever your phasing happens to be, I mean, I think by now we know big bang approaches are really not the way to go, especially for anything at the enterprise level. Break it up into reasonable phases. And the one thing I wanted to call out, though, notice the green boxes on this roadmap. You see phase 4 in green at about the 12-month point is something I call the architectural tune-up, which then also resurfaces at about the 24 to 27-month point. One of the things I strongly recommend, and I've been doing this with enterprise data warehousing strategies for years and continue to do it as well, as I put together roadmaps, think about all the things we've talked about and everything that's going on. What you want to do is periodically sort of take a break from doing new functionality, take a look at what you've put together and think of it as tuning up your car. So you want to maybe get rid of any interim data feeds you've accidentally put in or had to put in. There may be certain aspects that are suboptimal you want to change, whatever it is. For 2-3 months, if you're able to do it, stop or at least put the new functionality on a slow burn, focus primarily on tuning up your architecture, and then you can keep moving forward and do that on maybe afterwards in every 15 to 18 month basis. So here's a couple closing thoughts. So think of this as a little pep talk. When you're dealing with enterprise data management, be prepared for false starts and be prepared for a challenging, difficult journey. There will be barriers and challenges that you will run into. We know a lot of them, but also there will be those, so-called unknown unknowns, things that just aren't even on your radar, whether they're technology-based, whether they're process or workflow-based, whether it's human or organizational factors. There will be things that aren't on your radar. Get ready for them and be prepared to address them. Be prepared to change gears, especially over a long time, because what you want to do is build something that evolves. So in the Data Lakes for Dummies book, I talked about, I call it the B-52 bionic enterprise data paradigm. So in the United States Air Force, there's a plane that called a B-52 that originally came in service in the very early 1950s. Now, the average lifespan, at least back then, for a U.S. Air Force plane was roughly in the 25 to 30-year time frame. So if you do the math, the B-52 should have gone out of service, should have used up its useful life somewhere around 1980 or so. The reality is the B-52 is going to be around for 100 years. It's now scheduled to go out of service sometime in the 2050s, so about 30 more years from now. Now, here's the punchline. If you take a modern B-52 and put one side by side with one that came out of an air museum from the original generation, and you look at them, they're going to look pretty similar. But if you start digging inside, you look at the avionics, you look at the flight controls, you look at all the different subsystems, some of them are 2 or even 3 or 4 generations removed and better than the original versions were. So this paradigm of swapping out subsystems, having a very component systems-oriented approach to all this is critical for enterprise data as well. When you build your enterprise data environment, you do not want to be going back to the drawing board and rebuilding everything every 5 or 10 years. Things will change. New technology will be introduced, new paradigms. You want to prepare for those. You want to have long-term evolution in mind and then essentially operate that way. So if you want any more information about any of this, On the more tactical side, I have a couple courses out in Udemy. They've been around for about a year or so, kind of the golden oldies, data warehousing fundamentals, as well as data modeling fundamentals. I mentioned the Data Lakes for Dummies book. It's sort of this is the modern approach to data lakes, to new generation data lakes. I'm also working on a new book called The Business Hypothesis Imperative, which is about think of it as the business process side of analytics and enterprise data management. And with that, I'd like to thank all of you for attending, and I'm open to listening to any questions.
Thank you, Alan. Great presentation. I took my notes, even though I've been for almost 15 years, I've been data warehousing consultant and architect. There were some things in your presentation that strongly resonated with my experience, but as well some new ideas. Actually, I just would like to kind of like take the opportunity and to ask my first question, because it is very close to like this last book that you mentioned, about the business side of data architecture. It is the Oktoberfest, it is primarily for techies, but every one of us is obviously facing the management, business side in our jobs. So like two things that you mentioned that I would put in this bucket is one, the balance between vision and pragmatism, and the other one, be prepared to change gears. And from all your experience, kind of like how often have you met these leaders, no matter if they were on business side, on technical side, who actually were able to balance this vision and pragmatism, and on the other hand as well were like strong enough to be able to change gears in the running programs?
I will be honest, it is hit and miss. You hope that you are working with or working for someone who appreciates this philosophy. Now, especially as an outside consultant, you don't necessarily have control over your clients' let's say a particular manager's philosophy. You essentially have to play the hand you're dealt. Then the other challenge is, let's say from an outside consulting perspective, even if your client fully appreciates the balance between vision and pragmatism, fully understands that changing gears is part of it, that person may have his or her own constituents on the business side, the technology side, whatever within his or her organization. You're the outsider. It is one of the most challenging aspects to enterprise data management. So one of the things, essentially being a consultant and a consulting executive, as well as, sort of studying this area, enterprise data is not only about data, nor is it only about advanced technology or emerging technology. It's that, we all see the triangle of human and organizational factors, work processes and business processes, and then technology, and the necessity for all three of them to be in play. It's a cliche, but some cliches are true. So to your question, it is hit and miss. Sometimes you are proverbially, preaching to the choir, as they say. You're the stakeholder is fully aware and fully appreciates this and is the perfect client or the perfect boss. Other times, you just got to play the hand you're dealt.
Mm-hmm. Okay, thank you. Actually, we do have questions in the chat, so let me start with the first one. Asked by Andrew Diaz. His question came before you presented this Lambda and Kappa architectures, but I believe that this is a very common question that most of us hear all the time. So is data warehouse still relevant? I see data lake should be better approach for an enterprise. What is your comment?
Data lakes better approach from the enterprise. Well, I mean, I guess the way let me take a step back, and I'm not sure if this is directly answering the question. One of the challenges we all face is and I'll phrase it this way: the latest new shiny thing. So at one time, enterprise, first generation enterprise data warehousing, that single monolithic entity that would be the end all, one-stop shopping, was the way to go. We're talking the early 90s with early 90s technology. And, most enterprise data warehouses kind of collapsed under their own weight in those days, which led to, kind of a fragmentation into this world of data marts, whether we tried to link them together through conformed dimensions or whether we just kept them truly independent and said, presto, you are a federated EDW, even though I'm not unifying anything. The terminology is not necessarily the important thing. And a great example is when I wrote Data Lakes for Dummies, one of the way I started off, I think it's chapter 3 about challenges, is there's a little picture with like an A, B, C, and D on it. And I go, okay, which one of these is the data lake? And the answer is, could be any one of them. There's no standard definitions for any of this. So if you take a step back from the terminology and think about what it is we're trying to do, we are trying to ingest, manage, organize, and then present for consumption a combination of structured, unstructured, and semi-structured data. We want to have that thing evolve. We need to manage that. Regardless of the terminology we use, and let's take a curated package of data within a data lake, which happens to be dimensional. Some people would consider that to be part of the data lake. Others would say, nope, that's a separate data warehouse. The terminology is not the important thing. It's the overall architecture. So I hope that answers the question.
Yes, and actually, I will ask questions or read questions in slightly different order than they were asked, but I believe the next one kind of like builds up on the previous one, where every next hype is taking place, and this is where Tolga is asking, should we forget data lakes also after we've forgotten data warehouses and consider data mesh? Then we will.
Okay. I'm sorry, go ahead. Sorry.
And then when will we forget the data mesh?
All right, so about 4 or 5 years ago, in the other side of my life, my university teaching life, I was doing some consulting to our internal university IT organization, and they were building out a data lake. So one of the things I did was kind of an early intro presentation. I brought out all these articles from our columns, blogs, whatever, from a couple years earlier, from roughly the 2013, 2014 timeframe. The data warehouse is dead. Basically, everything was data lake. And at the time, most data lakes were Hadoop based. So the operating premise, or at least I wouldn't necessarily call it conventional wisdom, but the hype was data warehousing is dead. Everything's data lakes. After a couple of years, it's like, hey, you know what? They can coexist. Now we're seeing the data lake is dead. Everything is data mesh. Soon we will probably see, oh, the data mesh is dead. What did I call it? The data washing machine is the next thing. It's not the terminology. And in fact, one of the things, not to talk too much about the book, but one of the things I emphasized in Data Lakes, in the Data Lakes for Dummies book, is take a step back. Also take a step back from conventional wisdom about what a data lake is or isn't. Think in terms of enterprise data management. Think in terms of data pipelines. Think in terms of some data you may want to apply streaming analytics to it, but you don't want that to be a one-off solution. It's how you pull all these things together. One of the challenges we have is now, 31 years ago, Bill Inman said, this is a data warehouse. It's time variant, non-volatile, subject oriented, and integrated. So it wasn't exactly an ANSI or ISO standard, but at least we had something to go. The idea of a data lake is a lot fuzzier. So honestly, my perception is you can build whatever you want. You can call it a data lake. You can call it a data whatever. It's what you're building using modern technology that's relevant.
Sure. And actually, I didn't see this question, so I will jump ahead with my question once again. Um, and one of your slides was another buzzword from like, probably recent year, which is data lakehouse. What
Yes.
is data lakehouse?
Okay, so the flippant answer is it's whatever you want it to be. The somewhat, little better answer is it's an attempt to combine the best of the data warehousing world and the data lake world. So the premise behind that is a data lake is only for machine learning and neural nets, and it only deals with structured and unstructured data, unstructured and semi-structured data. If there's any aspect of descriptive analytics to it, it doesn't belong in the data lake world. Now, I don't subscribe to that, but that is one of the philosophies. So the idea behind a data lake house is, well, no, it's a data lake really, or we need to do more than that. So we're going to have a data lake house, and whether it's a downstream data warehouse that's connected to the lake, so the lake becomes a supersized staging area, or whether the part of the curated zone or part of your gold zone is actually dimensional data or columnar data that you would use for classic BI. It's an attempt to fuse both data warehousing and data lakes.
Thank you. There were a few questions from Timo Elliott as well, and actually I would I would start with the last question from him. Kind of like, this was all very manual. What about the opportunities to apply intelligence and learning technologies to the architecture itself, like self-tuning architecture, yes, etc.?
So remember, I'll first answer that by by couching my answer in balancing vision and pragmatism. The vision is that and this is absolutely correct, so much of what we need to do really needs to be lights out, or at least, kind of whether it's AI driven or not, you need to have kind of a lights out. So you look at a lot of engines for master data management and metadata, they essentially crawl through your data and discern what the metadata is, or other aspects, or whether or not something is compliant with master data. The more AI we apply to that, the better. Having said that, it is a matter of balancing the vision and the pragmatism. It's one of those where you would want to borrow from like the lean world, this concept of a model cell, where you essentially have a corner of, in our case, an enterprise data management environment. You try out a new technology that might be AI based before and prove it out before you essentially spread it out. And that's the other thing, just the corollary to that is, and this is not just today, this has been forever, products hit the market. Some work is advertised and some don't. So you do need to, in any of these corners of enterprise data management, prove these things out before you fully embrace them, and start building entire corners of your enterprise data environments before you do so.
Sure, thank you. There was a question from Subhakrishna. What do we do with terabytes of all data lying in legacy ERP?
So there's an interesting phenomenon to that. So with the data warehousing world, one of the cut lines we would usually make when we would build a data warehouse to start with was, all right, we do have all this historical data, but how much of it is truly valuable for analytical purposes, for BI purposes? And maybe it's only the last 3 years, or maybe it's the last 5 years, whatever it is of history. The rest of it leave in the ERP system, and the ERP system may indeed purge or otherwise get rid of that data after a certain point anyway. The equation is changed due to new storage models, due to, I talked about kind of cold storage or deep archives, just even. So for the longest time, data archiving was a totally separate discipline from data warehousing. Data archiving really is part of your overall enterprise data management. So whether you archive old data directly off of your ERP system and it's not part of your data lake, data whatever, or maybe you do blast the data in raw form, but just throw it right into cold storage. The other thing, I mean, part of that presumes that you do have a demarcation between your transactional data and operational data versus your analytical data. As we, continue to crawl towards this convergence onto multi-model database environments, and we break down this barrier, this whole idea of archiving the data that we may not ever need, or just might need if some odd event happens, definitely becomes a part of our overall strategy.
Sure. Actually, it is interesting that you mentioned this current multimodal approach as what was kind of like new. I felt that I spent 20 years on the market working, but it seems like I came to the market right after this, what you kind of like described as great convergence 1.0, right? So like when I came, it pretty much was all relational databases, right? And then what was happening in front of my eyes is obviously this whole Hadoop, NoSQL, revolution, evolution, and now this convergence. So it was quite interesting for me to have this aha moment, just like, oh, so what we see now is not something that is happening for the first time, and people who kind of like been on the market long enough have seen something like this already.
Yes. The saying goes, we've seen the movie before. And one of the advantages, like just for what it's worth, in my case, having been in the field for so long and seen a number of different, think of them as cycles of some of these same things, just with the newest generation, you develop kind of a sixth sense for immediately what is hype, what really shows promise, but might not necessarily be ready for prime time yet, and what is truly going to be a game changer. And you can essentially keep doing that. And the B52 model says we will not keep any of these environments static. You just can't. You could do that, but it's not going to provide the business value you need. There will be this constant evolution. You need to architect for growth, and you need to understand which new components, which new architectures, which new philosophies are the ones that you want to hang your hat on.
Sure. We are well over the time, but if you don't mind, just last question. I believe this is going to be short one. Andrew Diaz is asking, Alan, so when will your new book be released or going to be released?
The new one, probably spring sometimes. I'm working on a non-technology book at the moment. I have the business hypothesis imperative. It's probably about a third written, though actually I'm going to go back and make some changes. So it'll probably be late spring, early summer. At least that's the game plan.
Thank you. Actually, I promised this was the last question, but then one more question just from my side. So how many books in total, both like technology, business, and non-fiction, fiction that you have written?
I think I'm around 40 if you include novels, but I will say, so first of all, that's over since 1985. So what's that, 36 years now? Some of my technology and even my business books, I did as co-author. So I wasn't the solo author. In some cases, I was the subject matter expert. In other cases, like the 2 SQL books I wrote, I know SQL, but not as well as the editor of the ANSI and the ISO standards, the guy I used to work with. So he was the subject matter expert and I was the professional author. 2 of my novels I co-author with my wife. So I think the total's around 40 or so, but they're not all solo efforts. And again, it is over a long period of time.
That's impressive. And on this note, I just would like to remind everyone watching live or recording that Wednesday, tomorrow, we have 2 sessions at 2 different time zones with different authors who wrote and published different books on the SAP data and analytic topics. So we will be talking more how to start writing, how to find ideas, maybe how to live and how to survive publishing process. And as well, obviously, can you live just from writing books? But this all we will leave for tomorrow. For now, once again, everyone who joined us, thank you so much for your time. Alan, thank you for sharing your knowledge, lots and lots of really interesting discussions here. And with that, I wanted to say good night, everyone, because it is already night here, but for some of you in some other time zones, maybe the day is just starting. So have a good day or have a good night. Bye.
Thank you, everyone.